So example 5 is very similar to example 4. I've done this on purpose. I wanted you to see a less than and a greater than problem. This one says the mean weight of Angus steer is 1,152 pounds with a standard deviation of 84 pounds. What percent of steer weigh under 1,250 pounds? So this time it's going to be a less than problem. Assume you have a normal distribution, and I'm going to solve it with z-scores as well as the calculator. When I went back to make the videos and was rereading the notes, I noticed I did part A a little more complicated than I needed to, and I'll explain that when I do it. I do not want to redo all these pictures, though, so I'm going to go with it. What happened, I think I got in the routine of always switching over and using the negative side when I did the table. That's not necessary if I use the positive side, which, again, I'll explain what I mean by that in a second. So we have our distribution, which is centered at 1,152 pounds, and we have 1250, which is in front of that, and we want to find the percent that are less than 1250, so we would shade the area to the left, which is what the standard normal table does when we find the z-score. But if we're going to go through the table, we got to find the z-score, so we subtract the mean and divide by the standard deviation. So we take 1,250, that individual measurement there, and minus the mean, 1,152, divided by 84, we get 1.17. Okay. I could have looked in the table with the positive values, and I would just be looking for exactly the shaded area below or to the left of 1.17, and I could find that in a z table. What I did, for some reason, I was getting in the habit of using the negatives, I did 1 minus the value for z less than negative 1.17, okay, which would be the same value. So the probability that x is less than 1250 is the same thing as using the z-score. The probability that z is less than 1.17, which would look similar to this picture, but with 0 and 1.17. What I did instead was found the area on the other side and subtracted. It's equivalent. Wasn't necessary, but is equivalent. That allowed me to use the same negative table. I think at the time I just had the negative table in front of me. But we have negative 1.17, so we go down to negative 1.1 and over to the column for 7, and you get 0.1210. And so since I used the negative value, I had to do 1 minus that. And you get about 88%. When I do it on the calculator, we're going to see that we don't get the exact same value because we're not rounding as much. It's more accurate on the calculator using normal CDF, which is another advantage of using technology. But it's going to match to 88% when I do it. This, again, I've already worked it before the video, but I'll show you. I do second, variables, and well, we'll leave it like that. Go down and choose number 2. And we need to do from negative infinity to 1,250. Just accidentally maximize that thing. So you see the picture, we're going from negative infinity up to that value at 1,250. So for infinity, we use positive 1e99. For negative infinity, negative 1e99. So if I clear it out and retype it, I have negative 1 second comma button to get the scientific notation e99. And then you'd go to your upper bound of 1250, put in the mean and the standard deviation. I'd done a previous problem with the same values, so they're still there. Type in the new ones if you need to. Hit enter a few times, and we get 0.8783, whereas I got 0.879 using the table. I get 0.878 using the calculator, but if we round, we got 88%. Okay, I'm going to do one more. This one's definitely easier with the calculator because you have an upper and a lower bound given in the problem. The mean weight of Angus steers is 1,152 pounds with a standard deviation of 84 pounds. What percent of steers weigh between 1,000 and 1,100 pounds? And again, we're going to assume it's a normal distribution. So do it with z-scores, do it with calculator. So z-scores are always a little harder when you have to do the area between because the table is just set up for less than problems. But there's the picture of what we're trying to do. We have 1,152 in the middle. 1,000 and 1,100 are both less than that, so the area is going to look something like this. What I can do is find the two values from the table and subtract them. Okay. So I found the z-score for 1,100 by subtracting the mean and dividing by the standard deviation. I got negative 0.62. And then found the z-score for 1,000. Subtract the mean, divide by the standard deviation, got negative 1.81. So the probability that the x value, the weight of the steer, is between 1,000 and 1,100 is the same as the probability that the z-scores are between these two values, negative 0.62 and negative 1.81. I've got those reversed because of the negative. Those should be in the opposite order, but between the two numbers. And so the probability that z is less than negative 0.62 minus, if we do the probability that's less than negative 0.62, that'll be the bigger area, and then we're going to subtract off the little tail on the end, the probability that z is less than negative 1.81, which will give us our final answer. So as you can see, it's very easy to mix up some of the pieces here when you're doing it with the z table, so it's nice that we can use the calculator. But anyway, I went to the table and found the values for negative 1.81. It winds up being 0.0351. And then for negative 0.62, it's 0.2676. And subtract those off, and you get 0.2325. Okay. So it's definitely possible to do it with the table, but much quicker with the calculator. So we do second, variables, pick number 2. This time we have both bounds. We're between 1,000, a lower bound of 1,000, an upper bound of 1,100. So it's easier than a less than or greater than. We don't have to use the 1e99 or negative 1e99 because we have those two values. Same mean and standard deviation, so I'll just hit enter, and I get 0.2328 if I rounded, 0.2325 there. So again, a little bit of round off error using tables, but 0.2327 or about 23%.